The Dread Cat Bonkers commands me to convey how huge space is. I have to comply because she has collected a bunch of the red dots and has them all hooked up to car batteries. She wants to make some sort of death ray or something. My girlfriend Erin is excuse me, the Dread Cat Bonkers, not the mommy, Erin, is a huge Douglas Adams fan. And the late Douglas Adams ends up having an excellent quote about space. Space is big. You just won't believe how vastly, hugely, mind-boggling big it is. I mean, you may think it's a long way down the road to the chemist, but that's just peanuts to space. That basically sums it up. Space is freaking huge. The Dread Cat Bonkers lives in America, so she's used to dealing with miles. So if I end up slipping up and end up using miles instead of kilometers, please end up forgiving the both of us. The Dread Cat Bonkers promised to step on my sensitive parts every time I forget to include kilometers, and only include the backwards measuring systems used here in the United States. So if I forget to include kilometers, please forgive me, and please know that the Dread Cat Bonkers ended up stepping on sensitive parts of my body. It's pretty easy to wrap our heads around distances we deal with every day. A few miles, a few kilometers. Distances that a healthy person can end up walking. Many decades ago, before I was the two-legged slave of the Dread Cat Bonkers, when I was a junior and senior in high school, the high school I went to was 2 miles away, which is about 3.2 kilometers. It was roughly a 42-minute walk or a 10-minute drive. You know, being that age, you're not in a rush to get to school, but you're usually in a rush to get home or go out and party afterwards. Yay! Being young, dumb, and stupid. From my current place to my old job, it's about 50 miles, which is about 80 kilometers. And it's a 51-minute drive. Well, from my place now to my current job, it's only a block and a half, but that's, not even worth mentioning. But they say the average drive time and commute's about 20 minutes, which I figure would end up being about half of that. So, like 25 miles and maybe like 40 kilometers? So you get the idea. That's an easy enough to wrap your head around because, it's an average distance and it's something that everybody does just about every day. But even if you end up getting into continental distances, say from Portland, Oregon to Jacksonville, Florida, that's not even going to opposite corners of the continent. Not even close. It's easy enough to get an idea of. That's 2,938 miles, which is 4,728 kilometers. That's a 43-hour drive according to Google Maps. I figured instead of calculating it out myself, I'd end up using Google Maps because that would end up accounting for the different travel times on the highway and other various driving conditions. That's almost 2 full days to cross a continent. The Dread Cat Bonkers and I are going to go on the assumption that not everybody has been in an airplane before, but that everybody has been put in a box and taken to the vet's office at least once in their lifetime before. So, we're going to end up going with the car analogies and the car speeds. For most of the city folks, the highway speeds here in the U.S. tend to be 55 miles an hour, which would end up being 88 kilometers per hour. In the boonies, the speed limit tends to get jacked up to 70 miles an hour, which is about 112 kph. So I'm going to end up going with the average speed of 65 miles per hour, which is about 104 kph. Since we're going to be driving in space, the Dread Cat Bonkers says that we're not going to get stuck behind a school bus or some idiot that doesn't know how to drive. And since we're driving at car speeds, we're not going to worry about acceleration or braking or any such mundane things since we're traveling at speeds that we could end up taking. So such things like that aren't going to be factored into our drive times. For For shits and grins, I'm throwing in the comparison here. The 65 miles per hour or the 104 kph. We're going to compare to the Apollo 10 return trip from the moon on May 26, 1969. That went a whopping 24,700 miles per hour or 38,897 kilometers per hour. So you could see that there's a huge difference between the crafts that we sent to the moon and actual driving time. The moon isn't technically a planet, but I'm including it anyway because it's the body that we're most familiar with seeing in the solar system besides our own planet and the sun. To drive there at highway speeds, it would end up taking 151 days. That's just our closest neighbor in the solar system. To get to the other planets, it would take a lot longer. We're talking years. To drive to Mercury, it would end up taking just under 100 years. To Venus, it would end up being 45 years with no rest stops along the way. Mars, it would take almost 85 and a half years of driving. And it only gets worse from there because Jupiter would end up taking 685 and a half years of driving. Saturn, it would end up taking 1,390 and a half years to get there. Now we get to the butt of the solar system, the joke that everybody loves to make, the planet that everybody likes to stare at. Yes, we're talking about Uranus. It would take just under 2,970 and 3/4 years to get to Uranus. The last full-size planet in our solar system, Neptune, would take a whopping 4,745.53 years to reach at highway speeds. Sorry, Pluto. The Dread Cat Bonkers says that maybe if Disney had made you a cat character instead of a dog character, you'd be included in this, but Walt Disney had to screw it up, so you're not getting included, and you're not a full-size planet. You're a dwarf planet, like Doc, Sneezy, Dopey, and Bashful. Our nearer stellar neighbor is Proxima Centauri, at approximately 4.24 light-years away. If I did the math right, it would end up taking 7,441,338.04 years to drive there. For those of you wanting to hop in your car and drive out to Wolf 359 to collect any catnip that might be drifting around out there after the battle that took place there, it would take you 13,654,153.28 years to get there. And knowing the Dread Cat Bonkers luck, there wouldn't be a decent sushi place within a parsec of Wolf 359. The Dread Cat Bonkers was rolling around on the floor all covered with catnip when she ended up doing all the math for that. But she ends up assuring me that she does her best work in physics and mathematics when she's totally whacked out on the catnip. So if you find any errors, please don't end up alerting her. Just private message me and tell me, and I'll go back and correct it without letting her know. Otherwise, she will take those red dots that are connected to the car batteries and use the death ray, and I'm not sure exactly where she'll end up targeting, but I know one of the first targets will probably be me. So, yeah. That's just the type of feline overlord that she is. Compared to interstellar space, our solar system is crowded. It's the difference between going into the inner city at rush hour and being out in the middle of Farmer Jones's cornfield in the middle of nowhere, Iowa. A lot of the common space tropes don't end up holding up when you end up going into real space if you want to have a realistic campaign or realistic world building. The Dread Cat Bonkers likes a middle ground where things are somewhat realistic but also has a little bit of the rubber science. A lot of the science fiction space tropes are based on perceived naval tropes. The one that stands to mind is shipping lanes. In science fiction, it would end up being space lanes. On the oceans and Great Lakes, the water and land isn't really going anywhere. Well, technically the land is moving a teeny bit each year because of plate tectonics. In space, you have planets orbiting a star, the stars orbiting the galactic hub, the galaxies are moving, everything from subatomic particles to supermassive black holes and galaxies are affecting everything else's movement because of the gravitational and quantum forces involved. Because of the planetary motion inside of a solar system, once you get inside a solar system, there really wouldn't be a shipping lane as you would end up having from, say, Hong Kong to Los Angeles, because even with a fast transit time between Proxima Centauri and the Sol system of a few days or a week, the orbits of the colony world and the home world would change within their respective solar systems. In most role-playing games, you're not going to end up wanting to sit there and calculate out the orbital insertions anyway. Usually, if you're going to be that nitpicky, you're going to end up having a program to do that anyway, because you're not going to end up wanting to waste that much time at the table figuring the math out when you could end up being playing. Another major science fiction trope is CQB, which is close quarter battles. Pick about any book, movie, or TV show, and they're guilty of this. It's where the combat basically takes place when you're within visual range of the enemy. That's not gonna usually happen in a space combat. It's gonna end up happening when you're in sensor range, which is gonna be a long time before you're within visual range. In science fiction, there's a lot of different stealth technologies, but the one that never seems to get used is blocking infrared. Heat signatures are going to be the biggest bitch to end up trying to stealth. You can mask the radiation, you can mask EM and everything else, but your ship is still going to end up giving off heat. And an anomalous heat reading is going to give your ship away. It's going to give the enemy ship away. In normal space-time, your sensors aren't going to operate at faster than light speeds. Anything that you're going to perceive is going to come to you at the speed of light. So the idea of getting close enough to your enemy to fire missiles, phasers, lasers, or whatever is just stupid. You're giving time for your enemies to lock onto you and fire their own luminal energy weapons, which are going to fire at the speed of light. In other words, by the time you know that your enemy has fired at you, you're already hit. That's why close quarter battles are just not a good thing. They're not realistic. As your enemy's turning towards you, starting a full engine burn, and aiming its weapons, you're going to want to end up firing your lasers, phasers, near light speed matter cannons, and everything else you have that's going to end up firing close to or at the speed of light at the enemy before they have a chance to react, so that you have the advantage, so that they won't see what hits them until they're actually hit. Once sensor lag has been dealt with, you've confirmed a hit, their sensors, engines, and maneuvering thrusters might be damaged a bit. That's when you want to end up going with missiles and slower weapons to try to end up finishing the punch. For a real-world example, you can compare the dogfights of World War I to some of the simulations of modern jet fighters. World War I dogfights were in your face. They were close range, where some of the later NATO training and some of the training going on now with the jet fighters, it's over the horizon battles. You never make visual contact with the jet that you're fighting with. It's all done over the horizon through instruments. Another common trope is coming across another ship in the middle of interstellar space, whether it's a derelict, a broken down ship, or whatnot. The odds of this happening are about the same as enjoying Vogon poetry. However, with some artistic license, it does end up making a good role-playing game adventure. One of the next two podcasts, the Dread Cat Bonkers, will be talking about communications, as well as one on interstellar drives. If the ship breaks down a few light months or a few light years from any technologically advanced civilization, they're basically boned because they'll starve to death. or run out of other supplies that they'll end up needing to survive. But if you're within a few light hours, a few light days, there are some chances for survival or rescue. If they have some sort of fusion maneuvering drive, they could fire the fusion drive in short little bursts to attract attention. You could end up releasing and venting unnatural substances from the reactor. That would be particles that wouldn't be found in nature. Doing this for a few days, hopefully there would be somebody on the ship passing near enough, or perhaps at an early listening post at the outer reaches of a solar system, that would end up saying, Ricky, I'm getting these strange signals. Maybe we should send somebody to check it out. And there would be a hope for a rescue. My feline overlord has said that I have wandered too far from the original subject matter of scale, so I will end by going back to the scale of how big space is. So an astronomical unit, an AU, is 93 million miles, which is 150 million kilometers. That's the average distance from the Earth to the Sun. A Dyson sphere is a megastructure. It's way beyond our technical know-how, and there wouldn't be enough material in the solar system to build one anyway. It would be a hollow shell around our sun, which would allow us to harvest 100% of the energy coming from our star. The inside would end up being a livable surface, which would be about 550 million times the surface area of the planet Earth. So that's an idea of just how much we could fit in the shell at the average orbit of our planet.